This segment is brought to you by South Louisiana Bank. It's better when we bank together.
Welcome back to HTV College Prep. I'm your host, Dominic LaBeouf. I'm an electrical engineer at Louisiana Tech University. And in this episode, we're going to talk about the lifespan of a star. So stars have lifespans just like animals and plants do. And the way a star forms is via a nebula. A nebula is a big cloud of dust in the universe. A nebula is actually Latin for cloud. So there is a big cloud of dust in the universe. A star can form, but three criteria must be met. It must be between 10 to 20 Kelvin in temperature, must be very dense, and it also must be very massive. So if these three criteria are met, gravity will push this cloud of dust inward into itself and will form a baby star called a protostar. But there's also three ways that this just will not happen. And the first way is because of stellar winds, you can say. So if this cloud of dust is constantly in motion and kind of moving around itself, it will not form a star. If the particles are too hot, it will not form a star. And if the magnetic radiation of these particles is too big where it repels each other, it will not form a star. And the probability of a nebula forming a star is between 1 to 10%. So it is very rare for the universe to form a star. Once the protostar is formed and the nebula actually makes a star, it can take two different routes. The first route is it takes hydrogen and fuses it to make helium. So nuclear fusion happens in the star to give it energy so it can radiate heat. And this happens for less massive stars. But for more massive stars, it uses a process called CNO, which stands for carbon, nitrogen, oxygen. And it uses these three elements as catalysts to make nuclear fusion happen in a greater scale. So these stars are bigger and hotter and they burn up faster. And after this process happens, there's three more routes a star can take. They can form red dwarfs, normal-sized stars, and supermassive stars. Red dwarfs are the smallest type of star, and they can last for trillions of years. We have never witnessed a red dwarf die yet because the universe isn't old enough for them to have died in. But the fuel in the star is evenly mixed, so it can use all of it to completion. And when they do die, we hypothesize that they're going to slowly fade out of existence, just like a light kind of slowly burning up. For medium-sized stars, like our sun, they last billions of years. Our sun is 5 billion years old, and we think it has about another 5 billion years left to burn. And towards the end of its lifespan, it's going to expand into something called a red giant, and is going to burn up Mercury, Venus, and Earth. So once this red giant forms, it's a big ball of fire pretty much. And then after it uses all of its fuel, it's going to collapse back in on itself due to gravity and make something called a white dwarf, which can last trillions of years. It won't be as hot as our sun right now, or as hot as the red giant, but it'll use the last bits of its fuel, which is primarily carbon and oxygen, to burn. The red giant stage of our sun won't last nearly as long, maybe a few million years, because it's using all of the hydrogen and helium it has left in this big little burst of energy, and before it collapses back in on itself. For supermassive stars, their death can go into two different routes. So for less supermassive stars, they're going to burn And once they become a red giant, they're going to make silicon and iron, and they're going to do fusion with these bigger molecules other than hydrogen and carbon. And once that takes place, a supernova, which is a big explosion, will happen. And then the star is going to collapse back in on itself and form something called a neutron star, which again can last trillions of years after. Now, for supermassive stars, they're going to do almost the exact same thing. They're going to start doing fusion with these massive particles, form an even bigger supernova, but then they're going to collapse back in on themselves so much that they're going to form a black hole. The largest star that we have observed is called UY Scuti, and it is about 1,700 times larger than our sun. If it was in the center of our solar system, its radius would pass further than Jupiter's orbit. And also, there's more stars in our observable universe than there are grains of sand on our planet. Everywhere, including beaches and the ocean. So that's it for this episode of HTV College Prep. I'll give you all a little summary real quick. So if it's a small star, it's going to live for a very long time, and then it's going to burn out quietly. If it's a supermassive star, it's going to live for a very short time and then die very violently. So come back next week where we'll talk about something different. Maybe we'll stay on the same topic as the universe, or we might do something different. But thank you for watching.
This segment was brought to you by South Louisiana Bank. It's better when we bank together.